Alright, so this program will allow the user to enter 3 points. And then what are we going to do with those 3 points? Well, we found the slope already, but what did we really want to find? The equation of the lines. The program will compute the equations of the lines through all the pairs of points. Alright, so that's what this program is going to do. And we decided, so far what we've done is we created a function called slope, which allowed us to find the slope. So what else do we need to do to find the equation of the line? We need to find the y-intercept for each one, don't we? Okay. So a few reminders here. This thing up here that goes before void main, what's this called? The function. The header shows up twice. The header is here, and the header is down here. I think the other day I used the. That's right. I think I used the wrong word the other day. I think I called it protocol. It should be prototype. You put protocol in the left. It's prototype. It should be called prototype. So what is this? Why do we put this here? You got to let the program know that you're defining it. Just like up above, when we include IOStream, you got to let the main know that you want to use CIN and COUT. Or if you include CMath, you got to let the program know that you want all those math functions. Okay, so this thing is called the function prototype. Also, this part of it, without the semicolon, is called the function header. The function header must contain 3 things. What are the 3 things the function header must contain? It must contain a word right here, which is the type of variable. I need more. The type of variable the function will output, and the computer science terminology is return. So the kind of variable the function will return. So when this function runs, it's going to return a number, and the number is going to be a float kind of number. Functions can return integers, they can return floats, they can return decimals, they can return characters, they can return strings, they can return nothing in C. What kind of function would return nothing? Void. A void function, like void main, would return nothing. And in a little while here, we're actually going to write a void function to do something. All right, so the first thing that must be in the header is the return type, in this case a float. The next thing is this. What's that? The function name. The function name is the second thing. And then you have a set of parentheses. And what goes in the set of parentheses? What's that? The fancy C++ terminology is formal parameters. And I've heard other things too. I heard it called arguments, which is sometimes called that. I've heard a description of it's the variables that get sent into the function. And those are all correct. When you go to take your next test and I ask you what are the 3 things that must be in a function header, you can use the fancy words formal parameters, or you can say variables that have to go into the function. That's what those are. Do functions always have to have variables going in? Void main does not have anything going in. And again, in a little while here, we're going to write another function for this program that will be a void, and we'll see what we would want that for. Okay, so all this is the function header, and then for the function prototype, we put a semicolon at the end. So a semicolon goes here. When you actually write your function down here, your header has to match exactly, letter for letter, word for word. It cannot be different in any way, shape, or form. It must be exactly the same. So I highly recommend copy and paste to make sure it is exactly the same. There is no semicolon here, though. Rather, this function starts with a curly bracket and ends with a curly bracket. Okay? Questions so far?
Could you put that same statement with the void main function that have to be outside?
This,
The second quote slope for y2 val.
all this?
Yes, that have to be outside void main.
My guess is if you put it in void main, it'll probably work still. But it really shouldn't be in void main. It really should be outside of it. It might work. I'm not sure. I'd have to try it. I don't want to try it because I don't want to mess up my program because we're going to add more to it here in a minute. I noticed that a few of you were trying to use functions with the lab that I passed out on Tuesday, which was fine. I did not expect you to use functions for that lab. Some people in the afternoon class did it. One thing I noticed for some of you, and I spoke to you about this, typically the variable names that we use here, we do not use the same variable names in the main. Typically we use different variable names. Can you use the same variable names? The answer is yes, you can. But normally we don't because then it gets confusing as to which variable you're using where. The reason we can use different variable names, this variable y2 val only exists inside these curly brackets. So if I have another variable up here called y2 val, that variable will only exist inside the curly brackets for the void main. So you can use the same name and it will work, but it's not considered good programming. Typically we use different names inside the main, different names inside the function. Okay? Less confusion that way. All right, so where we left off with this program, we define these variables, and I should document stuff because you're right, I did not document. What were these variables for? Coordinates for the points. All right. And then I should document this function down here. What's this function do? Computes the slope and returns that value to the main. All right. So far, we have the user enter the points, like so. And then the other day, we were running out of time, so all we had our program do was to print the slopes. But that's not really what we wanted. What we really wanted to do was find the equations of the lines. And we said a minute ago, to find the equation of the line, I also need to know the b value, don't I? I need to know the y-intercept. So how am I going to find the y-intercept? Okay, so we did this before in a program. So to find the y-intercept, you need to know the slope, and you need to know one of the points. How many times am I going to have to find the y-intercept? 3, because I need it for 3 different lines. If I need to do the same thing 3 different times, that's a reason we use a function. We use functions when we have to do the same thing over and over and over again. So it seems like we want another function. So we're going to make another function. So we're going to make a function that computes the y-intercept, computes the b value in y equals mx plus b. That function, what kind of variable should it return, if any? A float. The b value can be a float. It's not always a nice number like 2. Sometimes it's 2.5. All right, so it should be a float. What do we wish to name this function? Y-int. Okay. I'm not sure if I can put a dash in a variable name. I don't know if you can do that or not, so I'm not going to take a chance. Okay. I'll just call it y-int. What kind of variables, if any, need to go into our function? Okay, so I need 3 things going in. I need an x value, a y value, and a slope. All right, so float. They're all floats, correct? Float. We said we need an x value. So I'll call it x value, comma, float, a y value. And the third thing, a float,
Plus, well, I mean, there's the function slope, but is there a variable slope?
there is right now a function called slope. Do you think it would be a good idea to also have a variable called slope?
Probably not.
Probably not. Again, we try to use different names.
Slope value.
Slope value, all right. Helps if you spell value correctly. Although the computer doesn't care if you spell it correctly or not.
Yeah, but you don't have labor.
Semicolon. All right, so there's our, what's that called again? Prototype. That's called our function prototype. Okay, so down here, we will make our, that is our function header that I just copied. Why is y_int underlined in green? That's a wonderful question.
Because you haven't made the second part yet.
Because I haven't declared the function yet. I haven't built the function. All I've given it is a prototype so far. So it's warning me that's not a mistake yet, but you got more work to do. So it underlines it in green rather than underlining it in red. Underlining it in red, as we know, means you got problems, kid. All right. Computes the b value in y equals mx plus b and returns to main. Go to bracket. All right. So what needs to be inside this thing? Well, I need the formula for finding the b value. What's the formula for finding the b value? Y divided by mx, that's almost correct. Yeah, remember, I'm going to write here, this is not coding, so don't look at this. Y equals mx plus b. How would we get the b all by itself? We would subtract mx. All right, so what we want is we want the y value minus the slope, which we called slope value, times x value. And then what do I, that's going to compute a number. What do I want this function to do with that number? Send it back to the main. So how do I tell the function, return that number back to the main? Just type the word return. So that's all that function's going to do. That function's going to compute the b value. Here's the formula for computing the b value. And then it's going to take that number and send it back.
Now, what will it store that number as?
What will it store that number as? Right now, it's not going to store it as anything. It seems to me as though up here in our main, we're going to need some variables. One that stores the slope, because we don't have a variable up here in our main that stores the slope yet. And it seems like we're going to need a variable that stores the b value. All right, so I think I need a couple more variables up here. Float, m value, comma b value. B value. To store m and b in y equals m. Alright, so that's what those variables are called. Alright, so let's see what our main will do right now. Our main will allow the person to enter the first point. Wonderful. Allow the person to enter the second point. Wonderful. Allow the person to enter the third point. Great. Then it finds, it says the slope is, and it computes the slope. Is that really what we want it to do? Do we want it to just compute the slope and print it? We should store the slope. All right. So I don't want to print anything right here yet, I don't think. And I don't want to print the slope. Rather, I want to store it. So how do I store it? So I do m value equals, of course I can't have an n line there.
And you have a value.
M value. All right, so it should be, let's start all over here. M value, that's my slope, equals, I'm going to run the slope function, and I'm going to plug in, I got to make sure I put things in the right order here, because we defined our slope function as y2, y1, x2, and x1. All right, so when the computer gets to right here, what's it going to do? It's going to see, I want to store something into this variable called m value. You told me use slope, so it's going to jump out of the main, and where's it going to go? Down here to slope. It's going to take y2, plug it in for y2 val, y1 gets plugged in for y1 val, x2 gets plugged in for x2 val, x1 gets plugged in for x1 val. It runs this formula and sends it back to here, so that number is stored into m val right there. Okay, so that's what that's going to do. It jumps, does the calculation, jumps back and sticks it in that variable. All right, so now we know the m value. What else do we need to know? The b value. All right, so how do I find b value? I use my y_int function. And what do I send to my y_int function? So the x value and y value, I guess I'll use x1 and y1. And it even tells me what I need to use. It warns me, hey, you need to give me 3 things. Comma. And what's the last thing I need to send? All right, look how we defined our function. In our function header, the order that we put things in were x value, y value, slope value. So when I send it, I want to send x1, I want to send y1, and then I want to send what? M value is the number that has the slope in it, isn't it? So m value is this variable which stores our slope, so we need to send that variable. M value. Semicolon. Okay, so now we enter our 3 points. This will find the slope through the first 2 points. This will find the b value of the line that goes through the 2 points. Now what do we want to do? Output the equation of the line. So how would we output the equation of the line? Okay, so a very simple way would go Cout the line through the first 2 points is and then we could go Cout y equals m value times x. I guess I don't really need a time symbol there, do I? Because that'll just be a number. Plus b value. Ah, so I was going to say that. So this will work, won't it? I don't need those things there.
But it might say x plus negative.
Even worse than that, you're right. It might say y equals x plus -2. Is the teacher going to like that?
I'm not.
Probably not, because he's a pain in the neck and a real jerk sometimes. It also might even say y equals 1x plus -2. Is the teacher going to like that? Probably not. What would the teacher want it to say? y equals x minus 2 is what the teacher would want it to say. So what do we need? We need some if statements, don't we? Now here's the deal. We're going to be computing 3 lines. And we're going to want to print this thing 3 times, aren't we? That sounds like we want another function that's going to print so that I only have to build those if statements once. I don't want to build the if statements for the first line, the if statements for the second line, and the if statements for the third line. I only want to do it once and then use it over and over and over again. So that sounds like another function. So printing quite often is a function. All right, so here we're going to go. Well, let's just run it first and see if it all works. See if we're getting an answer up to this point and see if it's the right answer. That would be nice to know. All right, so debug. Start without debug. Well, it compiled. That's a good start. All right, enter a point in the form xy. 1, 3. Enter a second point. What's that? No. 0, 0 is a very clever choice. Why is 0, 0 a very clever choice? Because I will know the B number is 0. 0 anything would be a very wise choice. Let's go with 0, 0 since that's what you said. And if it goes through 0, 0 and it goes through 1, 3, then what's the slope? 3, because it rises 3 and it goes over 1. So the slope has to be 3. The y-intercept should be 0. So we know what the answer should be. So we'll see if our program's giving us the right answer. The third point, what the third point is doesn't matter in any way, shape, or form because we're not using it for anything yet. 1, 1, just to make life easy to type in. So it says, the line through the first 2 points is y equals 3x plus 0. All right, so it is giving us the right answer. Would we really want it to say y equals 3x plus 0? No, we really would just want it to say y equals 3x. So there's another thing that we should correct. Okay. Our program's running and it's giving us the right answer. That makes us happy. Now we just got to make it look fancy. All right, so as I said, I think we want another function to do the printing to make our printing look pretty. What kind of variable is that function going to send back to the main? Nothing. All this function is going to do is print. It's not going to send anything back. It's just going to be a printing function. So what kind of function is that? That's a void. So we need a void function. What do we want to call this function? Print? I'm going to call it print equation. Oops. Print equation, because that's what it's going to do. Do we need to send any variables to this function? Yes, it needs to know. It needs to know the slope and the y-intercept, doesn't it? All right, so slope, that's a float. What do we want to call it? We used mval. We have not used mvalue. Oh, we used mvalue, didn't we? Yeah, we used it down here.
We didn't use mval.
We used mval. We used m. We haven't
We
used
used
m.
slope val.
All right, mval. And then float. Bval. All right, and then like I say, to make sure I do things exactly the same, I use copy paste. Function to print the equation in the proper form. All right, so we do want it, no matter what, we want it to print y equals, right? No doubt about that. All right, then what happens next? What are the bad numbers for m? M could be 1, that would be a bad number, or 0, or -1. Because if it's -1, then we just want it to print the negative sign. If it's 1, we just want it to print just X. And if it's 0, we don't want it to print anything. All right, so seems like we need some if statements. If mval, which one do we want to start with? Equals 1. Thank you. Absolutely, I need the double equals. If C out equals 1, then what do we want it to print? Well, do we want a space after the equal sign? Up to me, up to you. If I want a space after, I would probably put a space before. We'll do that, I guess. Put some spacing right there. We'll do it right there. So if m is equal to 1, then all I want it to print next is the letter x, correct? See out x. Else, what happens next? If mval equals -1. Do I need the curly brackets around the if statement? Which if statement? I probably should have a curly bracket after this else, because there is going to be other else's, aren't there? You're right. Curly bracket there. Curly bracket ends down here. What do we want it to print if the m value is -1? Else, if mval equals 0 was our other bad number, what do you want it to do? I don't want the x. I don't want it to print 0x. Break? Break what?
Out of
But I think I need it to do something. If m is 0, if the slope is 0, then all I want it to print is y equals the b number, right? So I still want it to print something. I want it to print b val. And then I want it to break and get out of here because everything's going to be done, isn't it? All right. But I have an issue for that part. So I think I need a curly bracket here. Like so. So that helps. And then I think I need a curly bracket here. This if. Breaks only break loops or case statements. They do not break if statements. That is correct. But I think we're okay. We're going to take that out. Let's see how it works here in a minute. All right, so far, if m equals 1, we did something. We printed just the letter x. If m equals -1, we printed -x. If m equals 0, we printed just the b value number, because that's all we wanted. What's left? Everything else. So else, all right, so what do we want to do if m is not the number 1, m is not the number -1, and m is not the number 0? We want it to see out m value, m val it's called in this function, and then x. So far, we're going to put mx. Then what do we want it to do?
Figure out if the value is positive.
Correct. So how are we going to do that? We've kind of backed ourselves into a corner. And what I mean by that is this one right here is going to cause us problems.
We don't have to see out the. You don't have to see out anything.
Okay. If m is 0, what do we want it to do? Nothing really, right? We don't want it to print the m, we don't want it to print the x. So, do we need this here?
Now just say if it's not equal to 0, see how m value x.
Okay, so I think this was a bad idea. If the m value is 0, we don't need it to print anything. In fact, we just kind of want it to skip. So there's a couple ways to handle it. We could just tell it see out, and just put a couple quotes right there, and then it won't print anything, right? Or we could have left this out altogether and just had an if m val does not equal 0, then print this thing. In fact, testing for m val equals 0 and having it print nothing is kind of foolish, but okay, we did it. We'll live with it. All right, so far we've got it set up so that it will print mx correctly. So far. And that if, all that ended right there. All right, so now we got to print the b value. So what do we want for the b value? Plus the b value. Well, if it's negative, it'll print the negative automatically when it prints the letter, when it prints the variable, won't it? So just b value.
We have a setup if you have m equals to 0, then it will print y equals plus your b value.
You're right. But we'll see if we can fix that later. So let's get it mostly working first, and then we'll tweak it because we do have one more issue. He's absolutely correct. So we want if b val is greater than 0, see out plus b val. Else, if b val is less than 0, just see out the b val. B val is equal to 0, what do I want it to print? Nothing. So why would I put if b val equals 0, then print nothing? If b value is 0 right now, what's it going to print? Nothing. So
Well, if m and b are 0, then you have to print 1.
so we do have issues still, you're right. Okay, well, let's run it and see what happens. Oh, we can't run it yet. Where the heck am I? Right here. I don't want that see out statement anymore. What do I want? I want to call the function. So the function was called print equation. And what do I send to it? M value and
No, we
In my main, I have to send variables that are defined in my main. The variable for slope in my main is mval. It's going to take mValue and store it to the variable in the function called mval. It gets confusing with variable names, I understand. And so in my main, this one's called bValue. All right, well, let's run it. Debug. Start without debugging. Advance. First point. 1, 3. Second point.
0, 0.
0, 0. Third point, doesn't matter.
1, 2.
Y equals 3x. It printed that correctly. Yay, it did not print the 0. All right, let's run it again.
1, 0.
That's a whole nother problem. How about with 0, negative 2? What the heck is that? 0, negative 2. And let's make it so that it has a slope that's negative. So one point is 0, negative 2. Give me another point so that the line will be going. 1, negative 3, 1, negative 5. Any of those would work. 0, 0. Y equals negative 3x minus 2. It prints that correctly. That's good. All right. We would still have more issues. And you're absolutely right. I've heard some good examples of where we would have issues. Let's say I gave it 0, 5 and 1, 5 and 2, 2. The equation through the first 2 points is y equals plus 5. Why does it say y equals plus 5?
Well, it's positive. That's no problem with that.
But that's not the way we would typically write it on a piece of paper, is it? It's not wrong, but it doesn't look quite right. So we would have to fix that issue. We would have a bigger issue if we gave it 0, 0 and 3, 0. The equation through the line is y equals, and it prints nothing. Right, if it's the line y equals 0, I need it to print 0. We don't have that fixed in our print thing yet. And then the worst case scenario that Alex tried to make me do. What if I gave it a vertical line? What if I gave it 2, 0 and 2, 1? Y equals infinity x minus infinity.
Hey, that works. Is it wrong?
It is wrong. It is wrong.
It gave you an answer.
All right, so we would need to fix, we still have some print issues. So moral of the story is, and we've seen this before, this function that tries to do the printing is significantly longer than any of our other functions, isn't it? Printing, to get things to print nicely, to get them to print pretty, is usually one of the hardest things to really make happen. And this is a very good example. We would have lots of issues still. All right, but
More if statements can fix that.
more if statements could fix that. But that's not what I want to do right now. What I want to talk about is, right now we're only getting one answer, the answer through the first 2 lines. How do I get the answer through the first and last point and the second and third points?
Copy and paste.
Basically,
Just change it.
I copy and paste this, and I change what I send, don't I? So now I want to do it all over again. So let's say I want to use the first point and the last point. What changes?
Your Y2s
Y2's change to Y3's,
and the X.
and the X2 changes to X3. So now I'm using X3, Y3, that's the last point. X1, Y1, that's the first point. What changes in this?
Now you can
I can keep that exactly the same because I'm still using the first point. When I go to find my B value, I can use either of the 2 points. I can still use the first point. What changes here?
the last.
So the first and last points is. What changes here? Nothing, because I'm still sending it the slope and the b value. All right. And then let's say I want to do the last 2 points. What? So y. So do I still want y2?
Yeah.
Yes, but I don't want y1. I want y3, and I still want x2, but I want x3.
Although, are you going to want this?
Does it matter which order you put them in when you find the equation of the line? No, it doesn't matter which order they're in. Okay. B value, do I need to change anything in this line? Yes. I don't want to send x1 and y1 anymore. What do I want to send?
X2.
x2, y2, or x3, y3. I could do either one. x2, x3. Or x2, y2, I mean. And then this would be the line through the last 2 points is. And what changes here? Nothing. The only thing I think I'm missing is down on this print function, way down here at the end. I think I'm just going to put some spacing in.
Yeah, that way you can see it better.
That way the lines will be spaced out and I'll be able to see it better. All right, so let's try it. Zero comma 2.
1, 4.
1 comma 4. Negative 3 comma 6. The equation through the first 2 points is y equals 2x plus 2. The equation through the second 2 points is y equals negative 4/3 x plus 2, although it doesn't write it as negative 4/3. It gives you the decimal. And the equation through the last 2 points is y equals negative 1/2 x plus 4.5. Not bad.
We should do a right triangle.
What do you mean a right? Well, yeah, if we do a right triangle, then we're going to have well,
Line, a vertical line.
well, it depends on how you draw the triangle. You don't necessarily have a vertical line in it. Yeah. So. Anyway, I do think there's something missing from this program. And I think what's missing from this program is there's no directions to the user about what this program is going to do, is there? It just says enter a point. And you're sitting there wondering, why in the world do I want to enter a point? What's it going to do? So I think we're missing directions. It's a surprise. That's a surprise.
Then maybe they should have looked at the code. You know? In our documentation, they should have go over it.
All right, so quite often, things like directions and your function and your header that you print on the top of each one, that stuff typically goes into a function also. So this function is going to print the directions. So what kind of variable is it going to return? Nothing. It's not going to return anything. It's just going to do a print. So we would have a void. I'm going to call this directions. And then what kind of variables do I need to send to it? Nothing, because all this thing is going to do is print some stuff. I don't need to send it any variables. Okay. So, create my function. Way down here, make a new function. Yes. Go ahead. Yes, the functions need curly brackets. No, if there's more than one line, for example, you could do here, you could say float slope here equals, and then give it this formula. And then tell it to return slope here. Not good coding. Why not particularly good coding? I just made a variable that I really don't need to make. But you can have more than one line in a function, but they definitely need to be in curly brackets. You can define new, I mean, this function is like its own little separate program living here all by itself. So you can create new variables inside a function if you need to. You can do anything inside a function that you can do inside a program. This will work. It will work completely correct. But again, it's really sloppy coding. You're creating a variable when there's really no need to create one. You're just wasting memory.
Do you call it other functions from a function?
You can call other functions from a function also.
So that for our output at the top, we can make that into one function. So instead of having 4 lines for each time, we just have one.
Say that again.
So the m value equals slope, all that down to the print equation, that could be another function, right?
So what you're saying is, yes, we could take this whole block here. We could create a function called everything. It would send these 4 variables, and then it would run this function, it would run that function, it would print this line, and then it would run that function, and it would do everything in one. So yes, you could call functions from a function. And we're going to do that, not today, but we'll do it later. All right, anyway.
Now, if you were to make a function, and obviously with the purposes of the details, if you write your entire code as a function, and you put it back into the void, do that.
Say that again.
Let's say you write your program inside the function, and then you just return some variable name into the void main. Would it run the entire program based on the function?
I'm not sure. Probably are limitations, but I'm not sure about that one. We will talk about recursive functions later. A recursive function is a function that calls itself. We will do recursive functions later in this semester, yes.
That seems interesting.
It is interesting. So anyway, the directions are this program will allow the user to enter 3 points and will compute the equations of the lines through all the pairs of points. So quite commonly you would have something like that. Directions that you're sending to the user, those would just be put in a separate function also. So I should come back to my main, and before I have the person enter 3 points, I should give them the directions. So how do I call that function? Directions. Just like that. That tells it, jump down, run that function, but I didn't need to send that function any variables, but I still got to put those brackets there. I got to put the parentheses, because it's calling a function. I have to put them there even though I'm not sending any values to it.
So why not directly say
Yeah, why did you make the function?
Why would you
put it in there?
Because I feel like we're making more work.
I mean, you ended up with 1 line.
What if the direction?
First off, I wanted to see if it works, and it does. This program will allow you to enter 3 points and compute the equations of the line under the point. So it's all working.
Keep your void main organized.
Well, you could write a header program and then call that header program for every.
Then you could write a program called program. Keep going.
All right, so to answer your question, why wouldn't I just do some cout statements right here that print the directions? Well, one, I wanted you to learn how to create a function which takes no inputs and has no outputs. So I wanted you to see that because you will want that occasionally. But when programs are written, this void main right now has more in it than most stuff actually will. Very well written programs will be very function driven. And so pretty much all you will see inside the void main is declaring some variables, and then you'll just see a list of function calls. Almost nothing actually goes in the void main. Things, when you write programs, are typically very, very modularized. And the reason they're done that way, for the most part, is when you're writing a large program, you don't write the whole thing. For example, this program, Visual Studio, one person did not write this entire program. This program, I'm sure, is broken into many, many, many functions. And some people were responsible for some functions, and other people were responsible for different functions, so on and so forth. And eventually it all came together in the void main, and the void main just calls function calls. Probably many, many, many of them. Correct.
Let's go for it.
What that allows you to do is update things quickly and easily. If I need to change the directions, I know where to look. I look for the module called directions, and I change it here, and I know it will change it anywhere that this is called. Because depending on what the person is doing, you might have different directions that come up. So you might need directions for one thing they click on, directions for a different thing they click on, so on and so forth. So you wouldn't normally have just one set of directions in a program. You'd have many sets of directions. Other questions? Taylor. So her question is, if I build a function in this program, can I call that function from a completely different program? The answer is yes, you can. The answer is no, we will not do that in this class. We will not do that. We won't have any reason for that. We're not going to have a function in one program that we really wish we had in another program, other than maybe your header function.
That'd be great, just like a header and all this stuff.
Normally, the way you would actually do that is you see here, there's something called header files. So normally you would create a header file. If you want the same header for every program, you would create a header file and call that in. And that's the way you would normally do that. But again, we won't do that in this class. We will not call programs from other programs. But yes, it can be done.
Do you use a library for it?
Honestly, I don't know. I've never done it. I know it can be done, but I haven't done it. My guess is you probably have to create a library. And that's what CMath is, really. CMath is really a library that you're calling in that has a bunch of other functions in it. IOmanip is one. IOstream, or not IOstream, FStream, IOmanip. Those are all different programs, really. They're really completely different programs that you're calling in to use to make your life easier, to make stuff work. That's what you want to do. Set width would be a function. Yep. Other questions?